So hopefully everyone's in the right place and is here to learn about how to make their views more performant in Tableau Server. If not, you got about 30 seconds to get out the door, otherwise you're stuck. My name is Jason King. I'm a developer here at Tableau Software, or at Tableau Software, I guess we're in Austin. Been with the company about 6.5 years, and my focus the last really 4 years have been on our browser client application and really focused on performance, pretty much since the Tableau 8 timeframe. Started out by working on our browser rendering feature, building out basically the bundling and packaging of data as we send data from server to the client, and then basically speeding up rendering and interactions in the browser so we can give faster feedback, better responsiveness to end users who are using server. So quick show of hands, did anyone make it to Alan Eldridge's presentation earlier today on design efficient workbooks? We got one. So there's going to be two, all right. So there'll be a little bit of overlap. I'm not saying that Alan took some of my content, but he might have taken some of my content. So there's a bit of overlap. I think I'm going to dive into a lot greater detail of the types of concepts he brought up. For those who didn't make it, I definitely recommend it. Alan wrote a white paper on basically performance, creating performant dashboards. It's about 80 pages. It's a long read, but totally worthwhile. So recommend that. As I mentioned, Jason King, that's me. So Alan makes the same comment, but want to start with a statement that is just true, which is if your workbooks are slow on Tableau Desktop, they're going to be slow on Tableau Server. If the root of the issue is your database is slow, your queries are slow, you have a bunch of table calculations or level of detail calculations, those aren't going to magically get better on server. And so really the first step when looking at performance on server is look at performance on desktop. Use the performance recorder as a tool to figure out where your bottlenecks are and try to optimize. For this talk, I'm assuming you've already done that. And I'm going to be focusing more on server-specific issues, not the, I guess, core issues related to, again, database, queries, calcs. There are a bunch of other talks here at the conference. I definitely recommend going to Alan's white paper as well, cover those in great detail. There are two scenarios you need to consider when you're thinking about performance on server. There is the initial load of the dashboard, so when the user first navigates to your view and they want to look at it. And we certainly all experience slow loading, probably Tableau dashboards, slow loading web pages or applications where you just disengage. You're not, it takes 5 seconds, 10 seconds, you just navigate to something else. So initial load is very important in engaging people and getting them to actually look at your content. The other scenario, which I'll talk about second, is interaction. Tableau is not just about building static images and static dashboards to show to people, but it's also about interacting with their data and asking questions and diving in deeper and doing analysis. And so we want not only the page to load quickly, but we also want users to be able to interact and get fast results to interaction so that they can perform another interaction. It remains responsive and they keep interacting. So that'll be the second kind of category I'll talk about later this afternoon. I think it's really important as we dive in this level of detail to have an understanding of how Tableau works behind the scenes, how a dashboard actually gets loaded when our server and our client communicate. Now I'm a developer, I'm not a graphic designer, so hopefully this is legible to everyone and makes sense, but basically have our server on the left and a client on the right, and by client I mean your web browser, maybe your mobile device, tablet, and the arrows in between them represent communication between the client and the server. And down the right-hand side here, I have little snapshots indicating the state of the browser that you'd see the visualization as it loads. So the first step in loading a dashboard is going to be As a user, maybe you have a bookmark saved for a dashboard you look at on a regular basis. Or maybe someone sent you an email with a link saying, hey, I just discovered this, check this out. Or perhaps you're just browsing Server and looking at the different workbooks and views that are available, and you find one that's interesting, you click on the little thumbnail, and now you want to load it. In those situations, the browser is going to send an initial request, HTTP request that just says, hey, I want to view this page. The server will receive this request, and in response, it's going to do a couple of things. It's going to load the workbook from the database, from Postgres. It's going to do a permissions check to make sure the user actually has access to this workbook. And if not, they'll be prompted to log in or maybe given an error message. And lastly, it's going to return an HTML document back to the browser. And this document's not going to have the description of the entire dashboard and how to render it. It really just has a little bit of content, some JavaScript that will tell the client how to collect information about the browser to know what capabilities are supported. When the client receives this response, it's going to execute the JavaScript code to detect browser features. It's going to check for things like, is HTML canvas supported so we can do local rendering in the browser there? Are data URI supported so we can support custom shapes and the way we encode those bitmaps to send them to the client? And it's going to collect this information. The size of the browser window is another piece of information we collect that determines dashboard layout. So it'll collect that and make a second request, passing along that information to the server. And the second request is what we internally call the bootstrap request. Bootstrap meaning it's asking for the data to display the dashboard at that point. And when the server gets this second request, here's where all the real work happens. Here's where the server is going to perform queries against your database. Compute layout, so figure out what marks are in your visualization, how big they are, what their XY position is in Cartesian space. And those two steps are in common between server and desktop. Then the next couple of steps are going to be server specific. We're going to take that information from the layout that is, like I said, our visualizations, also computing our dashboard. So maybe you have multiple vises in your dashboard and legends and filters, and we need to figure out how big each of those zones are. So that's part of layout as well. And once we have that, we're going to package it up, serialize it, and we use JSON serialization, so it's a text-based encoding, to send that data back to the browser so that it can then render the dashboard. Now that payload of data is pretty large then. It's all the data describing the position and color of marks, all the labels and information we need to show in legends and in filters. And so a little graphic here, a wheelbarrow just to indicate this is where the whole description of the dashboard then is given from the server to the client. And I'm using client and browser kind of interchangeably here, so hopefully it's not confusing. If any of my terminology is confusing, please raise your hand. I'm happy to explain. So the browser receives this response. It's going to process the data and decode it. It's going to then create elements in the HTML DOM, basically the visual elements you see in the web page. And then if it's a client-rendered visualization, it's going to render those vises from that data. If it's server-rendered, it will make a follow-up request to the server for the image tiles, for the images that the server rendered that will just display in the HTML page. So that's a quick, high-level overview of how dashboard load works on server. Does that make sense to everyone? Everyone follow along? Any questions on that?
Does any of these matter, what kind of a database or what kind of a server from the data side?
So the question was, does the type of database matter or affect the way this process works? And the answer is no. In that, I guess I'm grouping queries together. So definitely, depending on the type of database you have, the way that they're queries, the type of queries we build may be different. But in terms of this process and the data that's sent from the server to the client, it's going to end up being the same. Well, let me take a step back then. So in my statement that when it's slow on if it's slow on desktop, it's slow on server. There's a little asterisk there. Those of you in front probably were able to see, maybe in back not. There's actually a caveat where that is not actually true. And actually, things can be faster on server than they are on desktop. And this is due to a fundamental difference between server and desktop, which is on server, you have potentially multiple users who are all viewing the same dashboards or accessing the same database. And so we're actually able to leverage the work that another user did when serving your request. So we have a number of optimizations on server that are in place, and they're effectively a layer of caches that are there to leverage that information, reuse the results we've already computed for other users. In a scenario where you have multiple workbooks utilizing the same database or connecting to the same database, maybe you have multiple sheets in your workbook using the same data source, we may have already issued the query for the results that we need to serve the current visualization or build the current visualization. Well, we have a query case that will have that information, query cache, and if we already have those results on the server, we'll reuse them. We don't need to make that extra request to the database and wait on it. Next layer up, we have our model cache. So I mentioned that when we get the query results, we use that then to build our visual model, which is basically the description of which marks we have, where they are laid out in 2D space. If you have the same visualization used in 2 workbooks or 2 dashboards, we may already have the model, the visual model built, and we can reuse it. And so now we don't need to issue the query, and we don't actually need to compute layout. We can reuse that. And lastly, in 10.0, we added what we call internally the response cache. And this is best to explain with a quick example. So imagine you are on the analytics team for your company, and you build visualizations that your entire executive team looks at. Say it's your sales dashboard, and it's close to the end of the quarter, and the CEO is the first one in the office. They're an early riser, and they come in and they log into Tableau server and load that dashboard. They want to see how we're looking towards the quarter's goals. Now, they're the first person to access the dashboard, so unfortunately, the CEO is going to get the worst experience because we're going to have to actually do all this work where we're going to have to query the database to get the most recent data, compute our layout, build our visual models, package up that data, and send that all to the client, to the browser, so the CEO then gets the dashboard rendered in front of them, and they can now interact with it and see how things are looking. Now, 15 minutes later, VP of Sales comes in, and she wants to know, hey, again, how are things looking? Logs into Tableau server, clicks on the link to go to that dashboard, and we've already computed all those results for the CEO 15 minutes prior. So rather than have to query, layout, package data, we actually have the serialized response already there, just ready as soon as the request comes in to return it back to the browser. So that's what the response cache is this serialized payload of data just ready to send back to any user who wants to view that same dashboard. So in scenarios where you have multiple users viewing the same database, or I'm sorry, same dashboard, the traditional bottlenecks we're used to thinking about, queries, how slow your database is, whether your queries are parallelized, what types of calculations you have, those types of things aren't factors anymore because we compute them once and we're able to reuse the results. And now your bottlenecks are factors like the amount of data we now need to send from the server to the client, how fast your network connection is everyone on a fast corporate LAN in the same office, or maybe you're distributed geographically and so there's greater distance and different levels of internet connectivity. And also then, with how much data we send, then how much data the browser we need to process and how much we need to render, how many marks in the visualization. So it changes in these scenarios, the paradigm, the types of things we want to look at to be able to get better performance out of our dashboards changes. So I see some of you there looking a little thoughtful and hopefully thinking, this sounds really good. I like this caching thing. I'd like more of it. How do I make it more likely? So there are a couple of things you can do. Obviously, this is not something you can just enable manually. It's something Tableau server does automatically. But there are a couple decisions you can make to help make it more likely. One is use fixed size dashboards. part of the data that we package up and send from the server to the client is pixel level data. Basically, when we lay out the dashboard and figure out your viz is this big, it's in pixels and we send that information over. So if you have multiple users, they have different sized windows in their browser, and you have an auto-sizing dashboard, those values are going to be slightly different. And even if they're off by a pixel, we're not going to be able to reuse the cache data. We may not need to re-query, the data is the same, but we'll have to relay out, repackage, and send that over. So fixed size dashboards is the first. Second is client rendering. So I'll speak about rendering a bit more for those who aren't familiar. The response cache is only enabled for client rendered visualizations. So if you have a really complex dashboard with a lot of marks, Tableau is going to server render that and response cache won't apply. The third is user filters. If you want row-level security, well, obviously your different users have access or visibility to different sets of data. And in those cases, we're simply not going to enable this cache because we don't want to accidentally serve the wrong data to the wrong user. And so if you do have user filters enabled, you won't be able to benefit from response cache. Lastly, relative date filters. If you have date filters on your dashboard and you want to see the last 24 hours of data, implied in that statement is 24 hours of data relative to now. And now changes over time. So when your CEO viewed the data, the last 24 hours was some set, and when your VP of sales comes in, now it's a different set of data. We're going to need to issue a different query, not be able to use the results in the response cache. So if you are using date filters, use specified date ranges if possible. Now, big caveat here, I'm not saying these features are bad. I don't want to discourage you from using them. They're very valuable. They have analytical use. If you need row-level security, absolutely use it. Having the right data governance, having the right analytical tools and the right visualization is more important than a little bit extra performance. But if you do have flexibility, or if you do have a slow performance scenario you're trying to improve, or maybe you have a dashboard you know your entire dev org, for us it may be a bug tracking dashboard at Tableau. You know that there's going to be hundreds of people looking at it. Well, benefiting from this caching will be a good thing, and so I'll do what I can to make it most likely. So I mentioned render mode, and hopefully most of you are familiar with this. For those who aren't, just want to give a really quick overview. On server, we have two different methods of rendering dashboards. We have client rendered, which is the default. And in client render mode, we send, I'll say, lower level data. It's not necessarily the raw data from the database. It's been munged a little bit from the server to the client. And we send this so that we can actually render the visualizations and the marks in the browser itself. This allows us to do hit testing, determine selection, highlighting, some filtering. We can give better responsiveness because we can perform these operations local in the browser without having to communicate to the server. So rather than wait for a second round trip, depending on where your server is located relative to the user and what type of network connection they have, you can get responsiveness in less than half a second, so it feels nice and snappy. The trade-off there is we potentially have to send more data. Now we're sending potentially the position and details of marks, but also possibly underlying values so we can display tooltips and do highlighting and whatnot. And so it does come at a cost. And there's a threshold beyond which the amount of data we need to send would have a negative impact, a large negative impact on initial load time because it's just way too much data to send. And at that point, we will fall over to what we call server rendering, where we will do all the rendering to bitmaps on the server, basically just image files. We use the ping format, and send those from the server to the client rather than the raw data. And the browser is just going to show image elements in the web page. In this mode, then any user interaction is going to require a round trip to the server. If the user hovers to get a tooltip, we're going to send a request that said, hey, the user's hovering at this XY location. Please tell me what tooltip information to display. And when we get the server response, then in the browser we can display the tooltip. Similarly, if a user clicks to select a mark, we will send the request to the server saying, hey, the user clicked here. Tell me if the scene changed at all. Send me new image tiles if anything's changed, and I'll display them to see the results. So you get less interactivity in this regard. Hopefully a better overall experience, though, where we can now display as many marks, as complex a dashboard as you like, and initial load time is not horrifically slow such that users just disengage and navigate away and don't even look at the dashboards you spent so much time building. Hopefully it's apparent that client render mode is a better user experience overall. You get better responsiveness, better interactivity. As a result, we spent a lot of effort in the 10.0 timeframe revisiting how we determine whether to be client or server rendered. So prior to 10.0, the rule of thumb was about 5,000 marks in your dashboard. If it was greater than 5,000 marks, we'd server rendered. If it was less, we'd client render. And it was a little more complex than that, but that was a pretty good rule of thumb. In the 10.0 timeframe, we did a bunch of research, looked at a large set of workbooks off Tableau Public, about 1,000 of them, and collected all kinds of metrics about the dashboards, the number of marks, number of fields on tooltip, number of labels, number of encodings you have, anything we thought might be a factor in influencing load time. And we looked at that data and came up with a more complex heuristic. I'm not going to go into the details. One, because it takes a lot of factors into account. Two, hopefully as users, you shouldn't be thinking about details at that level. You shouldn't need to, hopefully. But as a result, more dashboards are now client rendered, and with the load times are in the same category as they would be for already existing client rendered dashboards. There were actually some outliers that were client rendered prior to 10.0 that were really slow to load that are now server rendered, hopefully giving a better overall user experience. And we also took the mobile threshold. So mobile devices we expect to be lower powered. They're generally on slower networks, over Wi-Fi. They don't have as powerful processors. They have less memory. And so we used a lower threshold when determining whether client or server rendered. And that was about 20%, I believe, of the non-mobile scenario. In the 10.0 timeframe, we bumped that to 60%. So on mobile devices, you should see more client-rendered dashboards as well. So the types of factors we consider now, post 10.0 or 10.0 and beyond. The mark type. If you have a polygon mark type, it's always going to be server rendered. That was true before. It's still true now. All other mark types should be able to be rendered in the browser. The amount of data that we send or will need to send to support the dashboard from the server to the client. And next couple slides, I'll get into those details. The size of the viz. If you have a big 10,000 by 10,000 pixel visualization you show on this awesome 100-inch TV that's some dashboard about your operations, I bet you have awesome movie nights, and please invite me. I'd love to come. But we can't client render it, unfortunately, simply because browsers can't allocate HTML canvas elements that large. So if you have really big viz, it's going to have to be server rendered. And lastly, as I mentioned, the platform. Mobile has a lower threshold because they're lower powered devices. Now, if you're curious how to know what render mode you're in, my normal process for checking actually is just hover over the viz. If it's client rendered, we'll draw outlines over the marks because we know the boundaries, and we can do hit testing really quick and show you as you move over. And my mental model is like a filled map, and you hover over and you'll see the outline of each geographic region as you move over it. Another way is if you add the JS debug flag as a query parameter to the URL, we'll actually show, hopefully this is visible, it's kind of low on the slide, I apologize. In the toolbar, there's a little indication here that will be B or S. B is browser rendered, S is server rendered. So that's another way to tell also. As I said, I usually just hover and you'll see the outlines drawn over all the marks, and that's the quickest way to determine. Now this is a Jedi level talk, so I assume you guys like getting down and dirty. If you're interested looking at the type of data, the what we're actually looking at to determine whether we're client or server rendered, we log it. It is in the VizQL server logs. I have the path to the standard install location of the logs up here. Now this big blob of text is pretty incomprehensible, probably not visible even to the folks in the front row. That's one line from the log file. So unfortunately, this is not something we expect any of our customers to look at, but if you want to dig in, the information's there. It's JSON formatted. If you search for server-telemetry, you will get matches of lines like this, and you can bring it into any JSON viewing tool you want, which will hopefully give you a much better view than a big blob of text. I use JSON view for the outline or the tree view on the right there with the little highlighted elements. Makes it a lot easier to navigate and look at the data. But again, not necessary to get any benefits out of Tableau. If you're curious, you can dig in and look at this. So I mentioned that the size or the amount of data we need to send from server to client is a big factor, obviously, in determining client or server render mode. It's also a factor in performance, depending on network connectivity. If you're on, as I said, a fast corporate network, maybe you're an analytics team that's all sitting in the same office, your server's right beside you on the same switch, the amount of data isn't a huge factor, just because you have really fat pipe between all the computers. Now at Tableau, we have Tableau Public, Tableau Online, where we have users all over the world with different levels of connectivity. The amount of data is a bigger factor for us. For those of you in distributed organizations, maybe you have offices all over the world, maybe you have executives who travel, people who go to conferences in their industry and are in their hotel rooms looking at data visualizations over hotel Wi-Fi that's slow, then the amount of data we send may be a bigger factor for you. So I have a dashboard here, one of our shipping examples, and here's the audience participation part of the talk. Anyone have any guesses as to what features or what elements of this dashboard are going to contribute to the amount of data we need to send to the client to render it? The highlight action? The ranking? Okay. In the customer ranking in that viz? Any other guesses? Filters? Yep.
Display tooltips.
Tooltips as well, yep. Yeah, I think you guys have gotten most of them. So I've circled in the dashboard just the elements that contribute. So as I mentioned, render mode's a big factor. If we're server rendered, the size of the dashboard is going to be the factor of the size of the image tiles, as well as the density on of your viz based on the compression used in the image. Now, if you're client rendered, we need to send data to support all of this functionality. As was mentioned, well, I'll start with marks. We need to send the X position, the Y position. If you have different encodings, so color and size and shape, then we need to send those values for each mark as well. So the more encodings, the more data it's going to scale based on number of marks. Filters and actions have the same kind of underlying cause. If you're going to filter based on a value, then for that field, we need to know the value for each mark. I guess to say a different way, if you have a filter, for each mark, we need to know the value for that field so we can do the comparison to say, does this mark, is it filtered in or out? Similarly, if you have highlight actions, say you have customer data and you click on a customer and they're in Texas, and with that selected mark, I want all other customers in Texas to be highlighted and brought to the foreground so I can see them all. Well, we need to send information about the state of each of our customers to be able to do that comparison. So for each highlight action you have, for each field that you're choosing to highlight on, we need to send the underlying value for each mark to be able to do that. Same idea for tooltips. If you have a tooltip with 10 fields, for each mark we need to have the value of those 10 fields to be able to display that data. If we're going to be client rendered and we're going to show it without asking the server. Now by default, Tableau adds every field that is a factor in your viz to the tooltip. So that might be something to look at if you're worried about performance. Just choose the fields that are necessary, that you want to communicate, that you think people are going to dig into. It's not necessary that all values need to be surfaced when the user hovers. Labels, we need to send the text, so we need to format it. Maybe it's a currency, and we need to format with the currency value, or maybe it's a floating point number and you only want so many digits after the decimal. We'll need to format that on the server and send those strings over to the client. Field maps are a fun one. Fun, I say kind of jokingly, but y'all are familiar with field map visualization is. You want to look at the United States, break down a population by state, and maybe color based on that population. To be able to render that visualization, we have to send the outline of each state to be able to draw it. Now, some states, like Colorado, are pretty simple. It's basically a rectangle. So as a polygon, that's 4 vertices we need to send. It's not that big a deal. Louisiana, on the other hand, it's a little squiggly over there. Definitely in the bottom right corner. And so to draw this, we need to send a polygon that maybe has 1,000 vertices. So now imagine you have a visualization that's looking at maybe voting patterns by county, topical subject, across the whole US, and you want to color. And so now we need to send the geometry for every single county in the United States that, I don't know how familiar you guys are with gerrymandering and the way we draw all the different lines and whatnot. Those are not going to be straightforward shapes, and so it's a lot of data we're going to need to send just to represent what we're going to draw. So something to keep in mind. And again, same caveat applies here. These are all useful features, and I'm pleased, hopefully no one's live tweeting. Jason King says, don't use highlight actions. They're slow and expensive. That's not my message. Delete that tweet, please. These are all very analytically useful. My message here is more, be careful when you use them. If you have performance issues, you have a dashboard that's already slow, these are some things maybe to have a look at. Things to keep in mind as you're building dashboards to try to build them as efficient as possible. But build the dashboard you need. Don't skip features just because it may incur a little bit of cost. Now, how big an impact can these types of decisions make? So this example is based on a customer workbook, actually, that crossed my desk in the past year. And this is not their workbook. I built an example from scratch to demonstrate it. I have 2 dashboards here. They look pretty similar. The one on the left requires 546K of data to be sent from the server to the client to render. The one on the right requires 266K. For those with great eyesight or sitting up front, anyone have a guess what the difference between the two is? Just shout it out. I heard filters a couple of times and a couple other stuff. I'll go with filters because that's the right answer, so that's what everyone said, I think. So both dashboards, the vises are identical. They both have filters on the same fields, and the only difference here is the type of filters that are displayed. Now I'll switch to Tableau to show it a little better. The dashboard on the left, we have a filter on customer name, and it's a drop-down filter. And as a user, when I click on this, I'm presented with every value, all my customer names. And I have a lot of customers. Now, as a user, not very useful, I'd say. So I want to filter. I want to just look for my name, Jason King. Am I really going to scroll down through thousands of items to try to find J's are down here somewhere? Let me make sure I don't go by it. Chances are I'm going to search. So this whole list, one, we need to send all that data from the server to the client that has the strings for all the names. And in the end, your user is not even going to take advantage of it. They're just going to search and type in and look at the results. The dashboard on the right, instead of a drop-down list, I'm using a custom value or a custom list, similar to a wildcard filter where we don't get a drop-down as a user. And I'm looking at this on desktop, not on server mainly, so I didn't have to worry about Wi-Fi going out or something like that. But you'd have the same thing on server. So the user is going to search anyway. When the user types in, on server, they hit enter, we will execute the search. We'll basically make a request from the client browser to the server. Server's going to compute the result set, return it back. So we avoid sending the entire domain of that one filter field. Now there is a little bit of a hit in interactivity. There's that round trip for the search results. But for your users who never modify the filter anyway, they're not paying any cost whatsoever. And for those who do, it should be pretty responsive anyway. If it's not, obviously revisit. Always test in your live environment and see. But overall, you should be getting a better experience for users, and you're sending a heck of a lot less data. And if you have a small cardinality filter, not as necessary, but if you have a really big domain, in this viz, it makes a difference of over 50% of the payload. That customer scenario that I saw, 77% of their payload was removed by changing the filter type. So a lot less data we have to build, package, serialize, send, decode on the client. So I've spoken to factors that influence payload size. Let me take the other side of it and talk about some things that aren't factors. If you have a workbook with a lot of data sources and each of those data sources have thousands of fields, that's not going to impact the amount of data we need to send from the server to the client when we are in viewing mode. Now, if we're using web authoring and we're modifying dashboards or vizzes or we're creating new ones, we need to send that data so that you can see what data sources are available, what fields are available in them. But in the common scenario where your users are just viewing dashboards that have already been published, the data sources, the fields, aren't going to affect the amount of data we send. Similarly, number of sheets in workbook. I'm constantly amazed by what our customers do. I've seen some people with workbooks with 1,000 sheets. I don't know how you manage it. But if you happen to have that workbook and you publish it, it's not going to impact your performance. Lastly, the layout of your dashboard. If you have a fixed size layout or a auto-sizing layout, if you have floating zones, if you have vizzes that zoom to fit or fit entire view, that doesn't change the amount of data that we send. In the end, we still compute the size of every zone in your dashboard and send an XY location and a width and height. And it's still true that if you used fixed size dashboards, we're more likely to hit the response cache, so you'll get better performance. But in terms of the actual data that we have to send, it's not going to have an impact. So I've spoken to, I guess, kind of an observational looking at your dashboard while you're building it, the types of things that will be factors in sending data. But you probably have a lot of existing dashboards. You want to know, are there problems here? How do I know if I'm sending a lot of data or not? And I'm glad you asked, because these slides would be wasted otherwise. You can use a network monitoring tool. This screenshot here is from Fiddler, which we use internally a lot at Tableau. And you can watch the communication between the browser and the Tableau server. And as I mentioned, that second request in the handshake back and forth we call the bootstrap request. And you'll find if you use a network monitor like Fiddler or Chrome DevTools will allow you to do that as well. There's a request in here that has in the URL bootstrap session. That is the bootstrap request. And if you select it in Fiddler, you can see the statistics tab I have here will show the amount of time it took. It will also show the amount of data that was sent in response. By default, it's going to show the compressed data because Apache front end is going to compress results, gzip them by default. You can decode or decompress and see the uncompressed number of bytes as well. And if you want to look at the actual raw underlying data and see what we're actually sending, not just the size in bytes, if you add the JS debug flag, it will disable optimizations we have in place. So when we serialize the data, we compress it as best we can, compress arrays, we move common values out into dictionaries so we don't duplicate them. If you use the JS debug flag, that will disable those optimizations and make it a lot easier then. If you go to the Inspectors tab and select JSON, you can actually see then a tree-based view of the response. You can view the raw response as well, load it up in Notepad, copy and paste the text to any JSON viewing tool you want to use. Again, JSON View is the one I use. There are some websites out there that will do it for you as well. You just copy and paste the data, and it'll give you a web UI that'll let you navigate the tree. But this will let you see not just the number of bytes that we're sending, but also the actual data, and see where we have really dense amounts of data we're having to send. So in summary on dashboard load, again, if it's slow on desktop, it's going to be slow on server. So understand what your bottlenecks are. Use Performance Recorder if you're familiar with it. If you're not, it's a tool in desktop that you can use to see on a timeline how long your queries are taking in layout and whatnot, so you can see where your bottlenecks are. Do what you can to make cache hits more likely. Use fixed size dashboards. Use user filters sparingly. Don't use date relative filters if you can avoid it or if it doesn't make sense. And do what you can to ensure that your dashboards are client rendered. And lastly, simplify your dashboard so that we need to send as little data as possible from the server to the client. And this will do two things. One, this will help ensure that we're client rendered so that then the response cache and other layers of caching are more likely. And the other is then network transfer time is less important, less of a factor. There's less work we need to do on the client to actually decode, render your visualizations. So that's dashboard load. Interaction, I think, is the more important subject in that this is what makes Tableau special. This is what makes the difference between someone just staring at an image really quick and not really understanding what's important and really understanding the message you're trying to get across and have insights, because you can hover and see tooltips, because you can select marks and see what other ones are related. You can go dive in and figure out, hey, this outlier, what are the details? So interaction is important because the speed at which we can give that feedback will keep users engaged. Hopefully they'll remember as we talk at Tableau, keep users in the flow so that you have somewhere you want to be, it's 3 steps ahead, you don't want to get 1 step in, you're waiting 10 seconds, and now you forgot, wait, what was I trying to do again? So I'll start again with a diagram, understanding how Tableau works behind the scenes. Now this right now is going to assume that we have a client-rendered dashboard in the browser. I have my little picture there on the right. And let's assume that user is going to click on a mark. They want to select one. So what happens when the user interacts in that way? Well, first off, when the user clicks, we're going to determine what mark the user selected, or which one they hit, not which one they selected. And we're going to send a request from the client to the server that says, please select this mark. The client's not going to wait for the response. It's going to issue the request asynchronously and wait to get called back whenever the server returns. And it's going to move on and actually compute the results, process the interaction locally. We're going to figure out in the browser, because we have the data, do hit testing. Which mark did you hit? Okay, let's select that mark. Are there any highlight actions? Yes, there are. Okay, let's find related marks and highlight those and bring those to the foreground. And let's redraw the visualization immediately. And at that point then, the user can move on to the next interaction. Maybe now they want to hover and see those related marks and find more details. Maybe they want to select some different set of marks. We're not blocked on the server response time to get this feedback and allow the user to move on to the next interaction. So this is the power of client rendering. In parallel, the server is going to be doing about the same amount of work, or the same work. It's going to be, again, figuring out which mark should we select. Do we have highlight actions? Okay, what marks should we highlight and bring to the foreground? Let's compute the new description of the visualization based on that highlighting and sending the results back to the browser client. And the client's going to receive this response. And so now it has basically 2 results from the same interaction. And so now it needs to reconcile those results. Hopefully they agree. Hopefully we have done our job as developers at Tableau and get the same answer from 2 different systems. If we don't, we have a policy where the server always wins. In those scenarios, if there is a disagreement, you may actually see a flash. I know that we've had bugs like this before. Hopefully we fix them. But if you do ever see that, It's generally indicative of we computed a result locally, the server computed one, they disagreed, and even though we displayed one set of results, we're going to override it with the new set. In the server rendered scenario, we don't get those immediate results. Instead, we do have to wait for that request that we make to come back from the server. And in the interim, we get to show the lovely spinner, this little middle visualization there. So the dashboard's going to gray out, the viz will gray out. You'll get the spinner, and the reason we do that is we don't know what kind of actions you have on the client. So we don't know, maybe you have a filter action based on selection, and so the viz is going to change drastically. And we don't want to allow the user to continue to interact when the thing they're interacting with may go away out from underneath them. So we'll show the spinner, we'll gray it out, and whenever the server's done processing the response, it will return the results to the client, it will send the new image tiles, the browser will display those tiles and will hide the spinner, and the user can interact again. Now, how big a difference does that make? Having to wait on the server round trip versus not? Well, this visualization is based on data off Tableau Public. And again, Public's a special case, I think, because we have users all over the world, but it illustrates the point well. The y-axis is interactions with different visualizations. X-axis is response time in milliseconds. Blue is the server response time, the round trip, and orange is the locally computed response. The numbers don't really matter. I think the size of the bars tells it all. You can hardly see the orange marks. For us on Public, there's an order of magnitude difference. For when we can compute the response locally, it will be snappy for users. It will be less than half a second, possibly less than a quarter second, that you'll get feedback visible and can move on to your next interaction. The server round trip can take anywhere from half a second to about 3 seconds, depending on the type of interaction. And that is the difference between something that feels quick and snappy and you want to keep using, and something that you click and now you wait and you have a pause and hopefully you stay engaged, but it certainly doesn't feel quick and snappy. Now, in your deployments of server, you may have a different experience. Again, depends on your network connectivity, where your users are located. But even without people all over the world, you will see a difference in response time based on having a round trip to the server versus computing it locally. I don't know if people are still feeling interactive here, but in terms of responsiveness, anyone have guesses, other factors beyond needing to round trip to server or not that will impact the feeling of responsiveness in the browser? Number of marks, yeah. Amount of data we need to send, basically, yeah. Anyone else? So I heard someone say something. Server load, yep.
Browser type, kind of like some might be more HTML5 compliant than others, or be able to handle that better.
Yep, type of browser. Yeah, I think you guys got the main ones there. So again, render mode determines whether we need round trip server to client. The type of interaction. Some interactions we can handle, process locally in the browser. Selection, tooltips, highlighting, some filtering, depends on whether you have slicing filters or not. Other actions we can't. Maybe you adjust a filter and you've extended the domain. We don't have the data in the client. We need to go issue a query to the database. Not much we can do about that. Changing tabs, keep only or exclude. There are a bunch that we just don't have the data already in the browser to perform the action, so we're going to have to ask the server for the results. The type of mark. So I mentioned already the amount of data we need to send for filled maps. Turns out they also can be really expensive to render because we're drawing these really complex polygons. Shape marks generally are pretty simple, pretty quick to draw. Rendering engines are really quick at rectangles, so bar marks are really fast. Circles a little bit slower. And it turns out in the browser, actually, transparent line marks are something that are slow for us to render. And that's largely because of how we render overlapping line segments to get a good look and feel with transparency. But those are ones that are definitely slow if you have a large number of marks. Server load isn't on the slide, but that's a good point in terms of if we do have to round trip to the server and the server's under high load, a lot of requests, then it may take a while to get the response. And lastly, as I was mentioned, browser choice. Not all browsers are created equal. This visualization is actually data from one of our nightly performance runs we run against our browser client code at Tableau. The y-axis is different tests. Most of these are rendering based on rendering visualizations. And then the different colored bar marks are different browsers. Red is Chrome, orange is Firefox, blue is IE, and the x-axis is elapsed time in milliseconds. So you can see, just looking at the magnitude of bars, they're actually order of magnitude difference in speed between some of them. Just looking at the top result, if it takes 43 milliseconds to render a visualization versus 300 milliseconds when I click and I want feedback then from selection, it's going to have a big impact on how it feels. When it comes to responsiveness of interactions, a big part of that is just the time we're measuring or perceiving based on I click, Tableau figures out what that interaction meant, and now the state of the visualization changed, so we need to re-render. Well, if that rendering time takes a long time, then it's going to feel slow to respond. Even if we can process, Tableau can process really quickly what changed, we need to be able to display it back to the user so they can see the change. So type of browser you use can have an impact. Of course, some organizations you don't get to choose your browser, some standardize. Bottom line is try it out. Try different browsers if you have that flexibility. See if there's a performance difference, noticeable difference as you interact with your dashboards, and use the best browser for the job. So I've covered a couple of these, but rules to follow, kind of summarizing here. Watch your filter cardinality. Use custom value filters or wildcard filters for large domains. Avoid categorical encodings for large domain fields. So if you have a, let's say, customer name from my example, and I put that on the color shelf. Okay, one, that's probably not very useful. Now I have 1,000 different colors. Not going to give me much analytical information there. The other is if I have the color legend visible, I need to draw all those 1,000 values in that color legend. It's the same problem we had with the filter. Watch the level of detail of your viz, basically coming back to the number of marks in your viz. Use aggregations where you can, or terminology some people use is guided analytics. Start at a high level of aggregation and let people dig in, dive in when they want to see more detail. The term I use for that, and I'll show a quick example, is a master plus detail pattern dashboard. And this is a nice way to show some more data off Tableau Public as well. So this is actually a dashboard I use frequently to investigate slow rendering scenarios. So we're collecting data off Tableau Public, and I can see the average render time of different visualizations of workbooks published on Tableau Public. And I can see this one's slow. There's probably, I think, 1,000 workbooks in here. I've aggregated based on average. Now, if I want to dig in and see, hey, what's the range of experience? Is it always slow? Are there a couple really bad outliers skewing the average? Maybe I should be using median instead. If I select this mark, I can actually go see all the data, the underlying samples. Now, there can be thousands of those. If I just send all the data up front, maybe I had a highlight action based on selection in the top viz that highlighted the marks in the bottom. One, when I first bring up this dashboard, I'm kind of barraged with a bunch of data and I don't know what's important. Two, I'm sending information to represent those marks that may not be relevant. Maybe the user only cares about one of these, to dig into one of these categories, and so we don't need to send all the underlying data. Let the user start at a high level. Cognitively, it's easier for them. Performance-wise, it provides a better scenario as well, because we only need to fetch the data for those other marks when the user interacts. Limit highlight actions. By default, I think Tableau selects all fields when you set up a highlight action. Be careful about that, because that means we need to send the underlying values for all fields for all marks to support that action on server. Instead, choose the fields that are just relevant that you actually want to show the correlation between. And if it is all fields, use it by all means. But if it's only one field or two fields, then choose those explicitly. And lastly, use transparent line and area marks sparingly. They're just slow to render in the browser because of the way HTML canvas rendering works. In the end, again, I'm not saying any of these are bad. I'm not saying don't use these features. Our goal here is to get insight into our data, to share our insights. So build the viz that you need. Make smart choices. If you have performance issues, here are some ideas, the types of things to look into. Here are some things to be careful about as you're building new dashboards. Now that is all kind of focused on, as I'm building, me thinking about features I'm using, the cardinality of my domains and whatnot. In the end, these things really don't matter if they don't impact your users. Maybe everyone is on a fast network. Maybe everyone's pages are loading quickly. Their interactions are happening fast. They're happy. Don't spend time trying to speed things up that no one has an issue with. Well, how do I know if I have an issue? How do I know if my users are having a good experience or not? Unfortunately, Tableau doesn't have a great answer here, I don't think, overall. We do have some built-in functionality, the server performance views. And that'll let you see average page load times for a given workbook. So you can see kind of a bucketized view of how long your views are taking to load on average, how many concurrent users you have. Internally, I've been using a different tool for the past couple of years. It's a homegrown solution that lets us see, basically we've instrumented our browser client code to collect information about page load time, interactions. So this is the little Easter egg at the end of the talk for those who stuck around. Web Client Metrics is the name of this feature. It's an unsupported feature, but it allows you to collect performance metrics about page load time as well as interaction. And so you can see, breakdown by workbook, how long did each load take for all my users? For each interaction with the workbook, broken down by the type of interaction, how long is the responsiveness? That data is reported back from the client to the server in HTTP requests. It gets logged in the Apache logs. The requests have this format. My mouse cursor is showing up, okay. In italics here, where you see in the URL /inst ? And then JSON formatted data that is that metrics information. Now caveat here, it's unsupported. It's going to increase your network traffic because those requests are coming from the browser to the client. Your log file size is going to grow because we're logging this information. But you can enable it using tab admin or modifying your YAML settings, and those are here on this slide. An example of a view that I've built based on this shows a breakdown, effectively the same type of bucketing. This is, again, data off Tableau public. And actually, I'll just switch over to the live workbook. So data off Tableau public, hour by hour, bucketing page load time. So I can see, on average, what's my user experience? Does it change as my number of requests per hour go up? So y-axis here is number of records. It'll let me go look at the slow scenarios, the red ones, and I can see the workbooks. And now I can go know, okay, hey, these are the scenarios that I need to go look at and see if there's a way to speed it up. Maybe I'm doing something silly in the workbook. Maybe it's the data source. Maybe it's my dashboard, the way I'm issuing queries. And similarly, I can see interactions here as well and see the response time to interactions. So I know not only page load time, but also, okay, of the people who load this workbook, how long is it taking when they interact? Are they getting a good experience? Or is it taking 5 seconds every time such that they're getting discouraged? There's a trove of data here. If you turn this on, enable it, look at the data, you can see the types of interactions your users are performing and the type of experience that they're getting. The slides, I believe slides for all these talks will be made available. Enabling this feature with these settings will get it in your logs, there's a script that I use to parse this data, create a CSV. It's going to be open sourced. Unfortunately, I wasn't able to get it published on GitHub before today, but will be published up there that you can run it against your access logs for anyone who wants to enable this, get the data out to a CSV that you can easily import into Tableau and do analysis. So if you're interested, speak to me afterwards, shoot me an email. The information is on the slides. Now, in terms of references, Alan Eldridge's white paper, as I mentioned, is great. You can download it for free. It's a long read, very thick, about 80 pages, but totally worthwhile. For those unfamiliar with browser rendering or client rendering, a link to our help page here. There are a number of related talks. I'll go back to the repeats in a moment. A number of related sessions on performance. There are talks on improving your databases and your query speed, improving your dashboards, calcs, and whatnot. So there's a performance tag you can search for in the app, I believe. Alan and Eldridge's talk, the times here have shifted, so these might actually be wrong. I'd recommend looking them up. Alan's talk on designing efficient workbooks, faster dashboards with performance best practices, auditing your workbooks for complexity. All will be great talks. If you enjoyed this talk and want to come back and see it again, I'd love to see you Thursday morning. Otherwise, if you have friends, colleagues you think this might be useful to, please let them know. Otherwise, I thank you very much for your time. Please complete the session survey. I'd love your feedback to know how I did, how you enjoyed the talk. And otherwise, thank you very much.